Hey everybody, it's EJ from eyedesyn.com, and today we're going to be talking all about the Mesh Deformer inside of Cinema 4D and how it can help improve your workflow, speed up your workflow when deforming high poly objects using soft body dynamics or skin objects. So this is going to be a little follow-up tutorial to this inflate or deflate objects using soft body dynamics tutorial that I did a while ago. Had a lot of questions about issues you may run into with a higher density mesh and your dynamic simulations kind of going all wacky and crazy and maybe exploding out. So this tutorial is just for you guys that had trouble with that, and just for those of you out there who want to speed up your soft body simulations using what's called a mesh deformer. All right, so here is our pretty dense mesh rubber ducky that we're going to be using to demonstrate the mesh deformer and the very basics of what the mesh deformer does. If I go ahead and just grab my mesh deformer here, and actually, you know, these icons are pretty informative. Basically, you have a sphere and then it's trapped in a cage, right? So the mesh deformer basically works like that. We have a cage that is then going to form that little object inside of it. So there's two things we need to do with the mesh deformer. The first thing is to actually apply this or place this underneath an object, or if we want this to deform multiple objects, we place them in the same level of hierarchy of all those objects. So since I have the main rubber ducky geometry and then the eyes are separate, I want to place this mesh deformer in the same level of hierarchy so it'll affect each of these three objects. If I just place this underneath the one object, it's just gonna affect the rubber ducky geometry and not the eyes. So we want this to affect everything. And then the next thing you need is a cage. You need to define a cage to be used to deform an object. So if you're familiar with the Ffd, where is the Ffd? There he is. The Ffd works very similar to the mesh deformer. So the way the Ffd deformer basically works is you have a box, right? And you can subdivide it however much that you want. So if I go and if I'm in my garage shading, and you can't really see the lines here, but if I make this editable, you can then see the lines, right? And if I go to my cube, click on X-ray, we can actually see through that. So this is basically like an FFD cage. And let me just bring an FFD object into the scene here. You can basically see this is exactly what we did. It's a cube that we can then use to select points and basically manipulate these objects or deform the mesh, as you can see that I'm doing now with our FFD deformer in the same level of hierarchy as all of our other objects. Whoop. And that's kind of the basics of that. You're using the box, you're using a cube with whatever grid subdivisions that you want to deform a mesh. Mesh deform works the very same way. So I have this cube. I'm going to place this outside of the hierarchy. This will be our box cage. And I'll then define this as the actual cage I want to use. Now you want to make sure that your cage is kind of encompassing the entire mesh, or you'll have some funky issues. And that kind of is mitigated by using some of these external options here. But let's just see if this works. I'm going to hit initialize, and you'll see that our box cage went invisible. And we can now move this, and this is going to work exactly like, that's kind of goofy, exactly like the FFD object. But the great part about this is that we can use this boxy low poly cage to deform this object via either moving points or polygons, or by using like soft body dynamics. So what we can do is let's create a disk object, and we'll just drag this down, make this a little bit bigger, and I'll right click, go to simulation tags, collider body. So this is going to be able to be collided into by other objects, other dynamic objects. And then we'll just make our box cage dynamic by going into simulation tags and clicking on soft bodies. So the same way that we can use this box to go into point mode and deform stuff, we can also use deform this box cage using soft body dynamics, and that deformation will be passed into or through the mesh deformer into these other objects, and you can see that that kind of worked, right? The thing is that we have very little geometry with this kind of box shape, and that the stiffness is a little bit too high. So if we drag or bring down the number of springs through these three different structural shear and flexion, I go over a lot of these soft body object options in previous tutorials, so definitely check them out. But basically what's happening is there's a spring between every point of this box, and since there's so many few edges, that the deformation's not really gonna do too much. Now if we bring the pressure down like that, we can see we got some funky stuff happening, but we basically are shrinking down this object here. So if I just decrease the pressure, you can see that if we go a little too low, we're going to have some intersection of polygons, and our ducky just flies south for the winter. But let's just go ahead, and you can see that this box is not a very accurate representation of this rubber ducky. We're losing a lot of the contours here and stuff like that. So what you're going to want to do, unless it's just quick and dirty, you just really want to make this really bouncy, bring the structural really low. Maybe that's good enough. Maybe this isn't colliding into anything else. Having this low poly box is perfect. But what you typically want to do to get if this is colliding into something else and you need to recognize some of these contours of this shape, what you would do is then do some, box modeling basically. So I'm going to turn off my mesh deformer, delete the box cage, and I'll just delete this box cage as well. And I'm going to turn on this cage that I already made. And basically what I did was just, create a cube, right? And then just made that editable, turned on X-ray so we can see through. And then you just start, modeling. So we're just going to select this face and then hit MT for extrude, and then just kind of scale this, move this into place, maybe do like a loop selection, hitting U and then L to select these edges. And it definitely helps to have a fair amount of modeling skill, or at least basic level modeling skills, to be able to make this mesh. But and I don't want to bore you with doing the whole thing here. But I'll just kind of get this started. We'll hit MT to extrude, and there's our little beak. And then we'll go ahead and maybe go down here on this bottom polygon. Let me turn off that disk object and just extrude down and just move this back. So we're just doing a lot of extrudes. So MT again, and kind of just scaling, and then MT again. And depending on how much detail you want, with maybe you want the tail to be super floppy, maybe we'll add a couple subdivisions there, because the more subdivisions, the more springs that you'll get in there. So now maybe we can do like a loop cut. So I'll hit ML, or actually MK for knife. The M key is very helpful. It just brings up this pop-up menu. So MK for knife. And then I'll just make this a loop cut. So I'll just loop cut it there. And then we can, bring in these couple of points here and make this follow the contour of the head a little bit better. And maybe these points as well. And then we can maybe do another loop cut, MK for knife, and then just go straight down the middle here. And this is just kind of really half-assing it here. But I just want you guys to understand that you don't need to be a good modeler to be able to make these little cages. You just need to be somewhat close to the contours. And again, if you want to make sure that the mesh is kind of totally encapsulating your original mesh, so you can see that the head's kind of sticking out here. So we'll just select this. Let's bring up our 4-up view, which is what we really should be doing. You can see there's no point here to kind of pull this this polygon back. So what we'll do is then do MK again, do another loop cut, and you can see that added a few more cuts that I can now adjust in here. So I really recommend doing, at least learning about extruding and loop cuts and stuff like that, and loop selection. So in addition to M to bring up a little shortcut key, you can also do U, and that'll bring up some of your selection options. So I want to do a loop selection, so I just hit U, and then if I look down to L, that's my loop selection, so I'll hit L, and then I'll just select this little loop of points and make that again follow that beak a little bit more closely. So again, just some basic modeling. I already have my cage already done here, as you can see. And just very boxy. You can see that my eye is kind of not fully in, but we'll be okay. You can see a little bit of his butt cheeks kind of poking out there, a little bit of his tail. But what we're gonna do is then use this cage, and let's bring back our disk object here. And then again, just like we did with our box cage, we'll just apply some soft body to this as well. And let's turn back on our mesh, hit initialize, and again, that'll then store that in the memory, and you'll see that our little cage went to outline mode, so we know that that's working, and then we'll just hit play. And you're gonna notice that we're getting these little streaks of where those little, where our geometry was poking out of that mesh cage, right? So let's just turn on, you can see right here, that was not in the cage. Again, the butt cheek, the back of the neck, all those things weren't included with the dynamic simulation. So all we need to do is say, external, outside of our mesh cage. Let's actually just grow that by the surface there, include it. We'll go back to frame 0, hit initialize again, and that should fix everything. So now you'll see that even though our little, the butt cheek and our eye were kind of outside the boundaries of our mesh cage, using this external surface mode kind of grew that boundaries a little bit to take into account those little bits and pieces that were outside ever so slightly of our mesh cage. So you can see that we have this low poly cage with the soft body dynamics driving the deformations of our higher poly object through or via this Mesh Deformer, which is really awesome. So now we can go a little bit crazy and maybe bring down these options here and have a deflating duck. And again, this is super fast, super speedy, and we're not having those issues with polygons colliding or exploding out or anything like that because we're using that lower poly mesh. Now, I'm kind of hesitant to even show what this might look like if we actually weren't using a Mesh Deformer and just applied soft body dynamics to this. I don't want to crash my machine, but let's just give you a little taste of what this would look like if we applied soft body dynamics to just the duck here, the high poly mesh. And I'm gonna hit play, and I'm probably gonna get a spin ball of death, and I am. And you can see that that is just gonna chug through and be just a disaster to try to use this in real world simulation. It's just taking forever, and it hasn't even hit the floor yet, and we are already 7 frames in, and it's just taking forever. So this is the benefit of with a higher poly mesh to use a lower poly cage that you make really quickly, using your in my case very limited modeling skills to create that outer mesh, and using that to drive our ducky. So the great part as well is that these eyeballs are separate, and they're actually included in the simulation. It's almost like they're stuck and connected to our duck main geometry using this Mesh Deformer because it's deforming everything underneath. I want to show another example of this as well, where I have a van that's made up of all of these objects, right? Tons of objects. Place them all under a connect object, which basically fuses all of that geometry together, treats it as one object. And then I just have a very simple cage that's just a cube. I didn't even make it editable. Have some soft body dynamics on this as well. You can see that again I have very low values in the structure, shear, and flexion. Basically that's the stiffness of these springs. And again, those springs are connecting each of these edges and points together. And you can see that using this mesh cage, it's making this very this object, this van that's made up of many objects, makes it very cohesive and makes it squishy. So very cool ways to apply nice squishy dynamics or just regular dynamics to an object without blowing up your system with all the high poly calculations. So just one more example of the Mesh Deformer. Here I have my little ice cream cones, and you can see that each ice cream cone is actually just a sphere and then a bunch of little spheres underneath it. And I just have a low poly cage here, as you can see, and I just have this dynamic simulation happening there as well, where I have the low poly cage deforming the higher density mesh of these spheres, and this is just a super fast simulation. So not only does the Mesh Deformer help you with soft body dynamics and dynamics in general, one way where it helped me out a lot is when I had like a IK rig character, right? So here's my IK rig, and it's using the skin deformer, the skin object to deform the mesh. Now, what happens if my client's like, hey, we actually don't want a smooth rubber ducky, we want a low poly ducky. So what I'm going to do is, I duplicated my duck, removed all of the IK stuff. I'll go into my polygon reduction deformer, place that as a child. I'm just going to hide all these objects underneath here. And let me just delete all the materials there. We'll just bring this, if we bring on the garage shading lines, you can see that we got this low poly. And then to really make this nice and low poly, we'll just remove the Fong tag, which is the smoothing between those points. And you can see, whoops, we can see that now we have a very chunky mesh. So what if we don't want to re-rig everything using this geometry? Well, we can use this ducky, this high poly ducky, to, we're kind of working in reverse, to deform this lower poly duck. So what I'll do is go and grab a Mesh Deformer, place this underneath our ducky, our low poly ducky, and then that mesh, or that cage, will be the ducky that's all rigged, that higher poly ducky that you can see right there. Just gonna hide that again. And we'll again use surface just in case anything's kind of poking out. Hit initialize. And now we'll actually, if I move my joint goal, you can see that I have my higher poly rigged ducky geometry deforming the lower poly mesh. So we don't need to like re-rig and re-skin and re-weight a lower poly mesh. We can just use the existing, ducky mesh with the skin deformer and the joints to have it drive a lower poly version of that. And this is very useful if you, say wanted to still have that higher poly mesh, but needed to make some edits. Maybe you needed to make the client says, make the duck bill a little bit bigger. Well, for that, you'd need to, turn off the skin, maybe re-weight everything. But what you could do is just, again, duplicate the ducky, remove all this, go and, if the client wants a bigger bill, we just boop. That doesn't look very good, but you get the point. There's this bigger bill, and then again, we'll use a Mesh Deformer, make it a child, get that higher poly ducky with the smaller bill, hit initialize, and this should work perfectly. So we got that modification to the duck bill, even though that looks really weird, but it's all driven by that original object. So we didn't need to re-weight or reskin or anything like that. We're just driving this edited mesh geometry using that Mesh Deformer. So actually, while we're on the subject of using the polygon reduction deformer, that's actually a great way to do a quick and dirty cage without needing a box model. So let me just demonstrate that really quick. So here's our cage box model that we actually made custom, right? And we'll just hide this. We'll duplicate the main ducky mesh, and we'll just delete all the materials and all that stuff. And let's just hide our ducky group as well. So here's our high poly mesh. We'll grab our polygon reduction deformer, and then we can just, increase or decrease the strength of the reduction strength to get our lower poly mesh. And you can see that, this is pretty good. We'll just make this all editable, and we'll just right click with both objects selected, go to current state to object. And what that's going to do is basically just bake down that polygon reduction into a new object. And this will be our low poly cage. So now what we can do is, if I turn back on all of our objects here, I'll delete the custom box cage that we made and modeled precisely for the contours here, and we'll see how this low poly cage works. So again, frame 0 and hit initialize. We got that external surface turned on because we definitely want that active, or because basically what the low poly cage is going to do is not be totally following the contours accurately. So definitely keep this on, and we'll just copy and paste by holding command, click, and dragging. Copy and paste that soft body dynamics tag from our old cage to our new cage, and just copy all the settings there. Hit play, and then we can see what this looks like. And you can see that we have a lot more geometry there than we did with our actual other cage. The one thing you may notice though is, because our low poly cage is made of tris, you might get some pointy edges and stuff like that. So what you can do to kind of mitigate any pointy stuff happening on your mesh is you can maybe place everything in a subdivision surface to smooth out that mesh a little bit more. Or you can just go ahead and grab a smoothing deformer and make sure that's in the same level of hierarchy as everything else. And you can see that we're kind of smoothing everything out a little bit. So sometimes you can get away with using this low poly cage, especially if you're not, deforming your object too much. So maybe I decrease or increase the stiffness of those springs and the structural shear and all that stuff. Maybe crank this up even more so it's a little bit more stiff. And you can see that just by using that low poly cage, this kind of works pretty good. And we didn't have to do any modeling at all. So definitely experiment. If you can get away with a low poly cage to do your deformations, go for it. If not, you might have to go to the manual way. But definitely have fun and experiment using both methods. Hopefully that answers a lot of your guys' questions on speeding up and solving any issues you may run into when trying to follow any tutorials or trying to apply dynamics to any objects where things start exploding out, polygons are exploding out, and things are going really crazy during your dynamic simulation. Using a mesh deformer with a low poly mesh cage will really prevent any of those crazy issues from popping up, and it's going to speed up your dynamic simulation. So definitely use that. Use the mesh deformer, get to know it, make it be your best friend, and make some squishy rubber duckies. Alright, so hopefully we can inflate your brain with more knowledge of how you can try to get more out of your soft body dynamics by using the mesh deformer to make those crazy high poly object simulations a little bit more under control. So if you have any questions about anything I covered in this tutorial, definitely leave them in the comments section below. I'll try to get to them as fast as I can. And if you make anything using this tutorial, using the mesh deformer, or using the deflation or inflation tutorial that I mentioned off the top, I'd love to see you guys deflate all kinds of crazy stuff. Or a rubber ducky maybe. So definitely shoot those my way. Share them with me on Facebook, on Twitter, on the Instagrams. Always love to see what you guys are coming up with out there. And as always, really appreciate all of you out there watching the tutorials. I'll see you all in the next one. All right, everybody. Bye.